Students, let us solve a question related to your grouping of resistors. Suppose 4 resistances, the values are given written in the board and they are connected like this. Across A and B, you need to find out the total resistance of the resistors. See, A and B means you suppose there is a battery which is connected across A and B. Clear? But here the question is, the resistances across A and B you need to find out in 2 situations. First situation, there is a switch S is open. Second situation is closed. First let us calculate with S open. See from the diagram, suppose you consider this is the positive terminal of the battery and this is the negative terminal of the battery. The battery is positive terminal, it is connected here, negative terminal connected here. So it means in this way the current will come. Let's say the current I amount of current is coming here. I am discussing the battery battery is open. Let us open it. Open means there is no connection between these 2 points. So in that case you see, if I amount of current will come here, see, it is very clear, 6 and 12 they are connected in one branch. So let's say I1 amount of current is flowing through that resistance and I2 amount of current will flow through this resistance. This I1 amount of current will come here to this point. In this branch, I2 amount of current will come here. As there is only one outlet, so I1 plus I2 means total I amount of current will flow. Here I is equal to I1 plus I2. Simple. So in this diagram it is very clear, 6 and 12 they are back to back as current passing through them are same. So 6 and 12 they are connected in series. So in this case, series means what? Net resistance will be R1 plus R2. So you can write this formula for series. R is equal to R1 plus R2 like this. And for parallel, your 1 by R is equal to 1 by R1 plus 1 by R2 plus like this. So you remember this 2 formula only. But that is the case of your series formula. This is for your parallel formula. So S open, in that case, your equivalent diagram will be how much? See, 6 and 12 they are in series, 12 and 6 they are also in series. So your equivalent diagram will be this and this. So 6 plus 12, the formula is here, as that 6 and 12, the upper part, they are connected in series. So 12 plus 6, it is 18 ohm, and this is also 18 ohm. And again, this point is A, this point is B. Now you see here, again, this 18 ohms, one end, and this 18 ohms, one end, they are clubbed together, and the other end are clubbed here. It means these 2 are there in parallel. So 2 resistors are here, 18, they are parallel. Means the formula you need to apply, Rp is equal to R1, R2 by R1 plus R2. So which means 18 into 18 by 18 plus 18. So it means 18 into 18 by 36. So by 2, yes. So which means this is 9. Remember, 2 equal resistances they are connected in parallel. So it means the resistance will be reduced to, see, 18. So now the final resistance is 9 ohm. It means the total effective resistance will be half of the one of the resistances. But for 2 resistors, remember this is the formula. 2 identical resistances, or that formula you can take, Rp is equal to R upon N. Here R is your 18, N is 2, so your equivalent resistance is 9 ohm. So which you got? That is the shortcut formula you remember. So this is your first part, is open. Now the second part is closed. Closed means we should be joined. Got? So in that case, you see here, In this case, again in the same manner, all of you just see, this 6 ohm and this 12 ohm, their one end are clubbed together and the other end clubbed together here. The same thing applies for this 12 and this 6. So we can have our diagram like this. This would be our diagram. Equivalent diagram can take here, like, let's say, as they are clubbed together, we can join these 2 points here and here. This would be your equivalent diagram. From here only, it is very clear that this 6 and 12 and this 12 and 6, these two are in parallel and these two are in parallel, and you see 6 and 12, they are in parallel. So we can apply this formula. Rp is equal to R1 R2 by R1 plus R2, means 6 into 12 by 6 plus 12. 12 into 6, 72, 18. The value will be 4 ohm. So it means this will be 4 ohm, this will be 4 ohm. So next equivalent diagram will be this is your 4 ohm, this is 4 ohm connected across A and B. A and B. So the net resistance, as you see here, these two, they are connected in series, and your effective resistance will be Rs is equal to R1 plus R2. This is the formula, which is 4 plus 4, 8 ohm. So this is a very simple question basing upon your grouping of resistances. Now the second question is, you see the diagram. In this question, 1, 2, 3, 4, 5, 6, 6 resistances, they are connected like this across a battery of 10 volt. The question asked here, find out the current reading in this ammeter shown. In this diagram, you have to identify how many resistances they are connected in series and how many of them are connected in parallel. So that you try to understand here a little concept. See, from here, suppose the battery is sending I amount of current, at this end I amount of current will enter. The same I amount of current will pass through this ammeter. Yes? So at this point, you see, here to this point I amount of current will come. All of you just see, these two, there are two branches here and there are two branches here, and they are, this end, they are connected to this point directly. It means this part is nothing, means there all the points here, all the points on this line, they are at same potential. Remember one thing, if in calculating your effective resistances, points where this you will find the potential same, you can club together, means you can join this, you can reduce this. Also the same thing will apply here, it means you can reduce this. So your next diagram will be like this. There will be a common point here, you can take this point here, and two, this is actually a point where 1, 2, 3 branches, 4 branches are there, 4 branches are there. Like see, one branch you take like this, where your 5 ohm resistance is here, means this 5 ohm resistance. Another branch is here, you can take it directly. Another branch is like this. This is a joint there. So till that point you take that 10 ohm resistance. Also this 10 ohm and this 5 ohm, they are also connected to this point. Means if you take that point to be your A and this point to be B, and your grouping of resistance will be like this. Means you can take another branch here like this, 10 ohm, and one interesting point here, this two 10 ohms, their one end is clubbed here and the other end is clubbed at this point. Means this two end you need to connect. You take another end here, they are connected to your 5 ohm resistances. Or if you see here, this 5 ohm, one end is connected to end A, this 5 ohms, one end is connected to A and the other end is directly connected to B. That's why this 5 ohm and this 5 ohm I have connected to end A here and end B here. All of you just see, this two 10 ohm, they are directly connected to the end B and the other end start to the common point where the other two 10 ohm are connected. So we can see here, these two 10 ohms, we can start from this end like that, or you can have a common point here. We can show you like this. They are joined here. We can have our equivalent diagram. We can write down the resistances 10 ohm, 10 ohm. This will be your 10 ohm. Now from the diagram it is clear. These two 10 ohms, they are connected in parallel. These two 10 ohms, they are connected in parallel. Now we can again reduce this diagram, and your reduced diagram will be like this. Let us join, take one 5 here, another 5 here. These two 5 resistances are this 5. These two resistances here 5 ohm, and in between this 5, 10 and 10 they are in parallel. Here also 10 they are in parallel. Two equal resistances, they are connected in parallel, or you can directly apply that formula R1 R2 by R1 plus R2, your RP, which is 10 into 10 by 10 plus 10, which is 100 by 20, which is 5. So means this equivalent is 5 resistance, 5 ohm resistance. The equivalent of this 2 is 5 ohm, and they are connected here. You can say here, like in this case, this is your 5 ohm and this is another 5 ohm. Got? They are connected across A and B. This is 5 ohm and this is 5 ohm. Now you see these two 5 ohms, they are back to back, because you see here, these two 5 ohms, they are connected back to back. Whatever current will come here, now we have reduced these 4 branches into 3 branches. If the I amount of current will come in here, I amount of current will exit at that end. If here it is I1, in this branch I2, this branch I3 amount of current, then I1 plus I2 plus I3 must be equals to I. Then the same amount of current will rejoin here and they will leave out of the circuit. Now you see, this I2 amount of current will pass through this 5 ohm, means this and this, they are in series. So two 5 ohm resistances they are in series means 5 plus 5. So the total resistance will be 10 ohm. Now again we can read out this diagram like this. One 5 ohm here, there, and one 10 ohm here, and one 5 ohm again here. This is 5 ohm, this is 10 ohm, and this is 5 ohm. All the 3 resistances, they have one common point here and the other common point at this side. This implies, since they have their one common end, means one end tapped together at one side, other end at the other side tapped, means these 3 they are in parallel. So their equivalent resistance I can find here. There are 3 resistances. So 1 by Rp, the formula is 1 by Rp is 1 by R1 plus 1 by R2 plus 1 by R3, which implies 1 by Rp is equal to, there is 1 by 5 plus 1 by 10 plus 1 by 5. So which is equal to, we take the LCM, 10, so which is 2 plus 1 plus 2, so 5 by 10, which is 1 by 2, and which implies your 1 by Rp is equal to 1 by 2 ohm. 1 by Rp is equal to 1 by 2 which implies Rp is equal to 2 ohm. So your effective resistance of this circuit is 2 ohm. Now the question is, what is the current flowing through that circuit? Try to understand. Here this ammeter is connected outside this network. It means whatever current is sent by the battery, all the current will be passing through this ammeter. Means the total current in the circuit we need to find out. The total current in the given network is what? Total voltage across the network divided by the R net. So which is 10 divided by R net, we got it is 2. So which is 5 ampere.